Hello, welcome to part 3 of the Godot flip screen tutorial. In part 2 we built upon part 1, which included simply flipping a screen using the cursor keys, to including this player controller, which could move around a screen but could not change the screen flip, which we still had to do manually. So in this version what we will be doing is linking the player controller to the map, so that when we reach the edges of a screen we can navigate automatically out, and of course we will be blocking exits to rooms that are not allowed. So in doing so we will be learning about resource sharing, Area2Ds and StaticBody2Ds. The first thing we'll do is some basic housekeeping from the previous lesson. So in our room data, which controls which exits are allowed from each room, I updated every array element so that the player could not travel backwards into rooms that they've just exited, because that is how we want this game to perform. We will also remove the enumeration which controlled up, down, left and right, and replace it with the built-in vector 2 directions up, down, left and right. In the game, to remove the enum, we replace the check of a valid number with a function called valid direction. And all that does is it checks whether the direction passed in, which is a vector, up, down, left or right, is in one of the built-in constants. The other thing we do is, because we're using the vector 2 for direction and not an enum, we can't get our indexes 0, 1, 2 and 3, so we write a helper function called array item from direction, which simply returns the equivalent 0, 1, 2 or 3 from a direction passed in. If you go to our camera node, which if you recall is a very simple node which contains a single function called setPosition, and we use that in our debug code to flip the screen, and that is done by setting the position of the camera. If all we wanted to do was link the player's position to the camera, then we could go into the player code and call setPosition based on whether the player is near the edge of the screen. However, there are two problems with that. If you look at this diagram, what we want to do in our game is, on some rooms we want to block an exit. So if you look here, we want to stop the player from actually exiting the screen. We don't want them to go any further. But in rooms where we do want them to exit the screen, we may only want to flip the screen once we get past a certain point. Because if we did it on here, it might not look very good. So what we need to do is we need to apply some sort of system to allow this. Now we can do it in code, but a way to do it without as much code and to provide more flexibility and make use of Godot's nodes is, in our camera node we will provide a static body around the screen that will either block or allow the user to exit, and we will then place some what's called Area2Ds, which are sort of soft collision points around the outside but slightly further offset. So in our camera node we will add a static body. A static body is a little bit like the kinematic body that we looked at with the player, but it simply does not move. It is fixed in one place. So as with every other body, we need collision shapes. So what we will do is add a collision shape 2D, and we will make that shape a rectangle. And what we will do is we will attach, or we will size it to fit exactly around the edges of the screen. So what we will do is we will put this one across the top. So we know that the width is 512, so we can do 512 divided by 2, and we know the height is irrelevant, so we'll just give it a size of 2. And then in the transform, if we set it to position 512 divided by 2, then if you look, we have a Area 2D node right here with one shape. And we can call that shape collision top. We can then duplicate that image and call that collision bottom. So all we need to do is change its transform to Y position 320. So as you can see, we now have 2 items. We can then duplicate it again and call it collision left. Now its position is going to be 0 on the x-axis, and on the y-axis we're going to be halfway again. However, the problem with changing its shape is this is a resource. This collision shape is a resource, so every item that we've duplicated will share the same resource. So as an example, if we resize this image, as you can see, it is resizing every item. So we don't mind the top and bottom sharing resource, it'll save memory. So on our left one, if we go to the rectangle, we can select to say make unique, and it will turn this into a brand new resource. So then we can reverse the item, so it's width of 2 and his height is 320 divided by 2, which gives us 160. So as you can see, we have a collision shape on the left. We repeat it for the right and change the transform to 512. So now we have 4 shapes, and what we will do is we will rename this and call it room blocker. And all we need to do to block the player is we need to set the collision mask to look for the player. Yep. The layer it is on is completely irrelevant, so we can just leave that blank. So if we just run our game now, what will happen is we are now blocked from exiting the room. If we go into the code for the camera, we can start adding some basic functionality. So if you recall, in lessons 1, 2 and 3, we've said the camera is only going to be used as a sort of dumb node. In other words, it's not going to know about any other node. All it's going to know about is its position and everything to do with itself. It won't be involved in room management. So we created a variable called block exits, and we will add a block exits variable, and this is more of a debug thing, and we can toggle it on and off to block or unblock the rooms just to make sure that the code that we provide works. We will also create an onReady variable that points to each of the collision items, because usually it's better to use variables to point to nodes in our code than the actual dollar representation, because if we change the nodes around, there may be a need to update lots and lots of code. And to add our actional functionality, we need a public method called setExits, and we pass in a boolean for up, down, left and right, so that when we want to block any one of our 4 exits, we can pass in the relevant Boolean. Now the way we do it is, if you recall from the node, we have a single static body with 4 collision points, and the way you turn collision points on and off is by using the disabled flag. So if it's disabled, it does not provide or perform any collision checking. So in the code, we have our array of items, and we set the disabled status to be whatever is passed in. The reason why we call set deferred is because collision updates can only be done within the physics frame. So using set deferred ensures that setting disabled will work. If we left it alone and simply said something like this, then it may or may not work. And we've also got a little debug statement just to help us along. So just as a quick test, in our ready function, if we do set exits like this, so if we run our game now with our quick test of set exit true, in other words, everything will be disabled, we should be able to exit the room. If we pass in false for everything, then disabled will be false, which means collision will be checked. So when we run our game, we cannot exit the room. One bit of functionality that may be useful for a game is to provide a means of locking the entire room. So if we create a function called lock room and pass in true or false, then we can call our helper function set exits, and it will lock or unlock an entire room. A use case for the lock room to actually lock the room is in a mini-boss where we do not allow the user to exit. So instead of calling set exit and passing in 4 booleans, we can just call lock room. And if we set a default of true, it will simply lock the room. If we pass in false, it will obviously unlock everything, which in our game we will never do. So we can then change our ready function to be simply lock room. So with these two methods, we're providing the ability to lock and unlock the room. And now that we've done the camera, if we go back to the game, in our game, we have the function called change room, and currently it is only called by the game code when we press left, right, up or down to manually update the rooms. However, we will be linking this to the player controller. After we've successfully set the camera position, what we want to do now is refresh all of those exits. So with the method that we've just written, we will get all of the exits for the room and call the method set exits. So get exits for all rooms will return the array for the current room, passing in the room in the up, down, left and right direction, or -1 if you cannot navigate to that room. So we then call set exits with the boolean of whether each item is not or is -1. So if we run our game and use the debug navigation, we can press left, but we cannot press right. We can press down, but we cannot press up or right or down, only left. So that is all we need to provide room blocking for the game. What we now want to do is provide the means of the player to exit the room and actually change the direction themselves. And we will do that by creating a Area2D to the same camera node. We will give this node the name Room Navigation. Now, an Area2D is similar to the kinematic body and static body nodes in that they are objects that have a collision shape and detect collisions, but the difference is it does not block. In other words, it is more of a soft collision. And the other main difference is the way you'll check for collisions inside of a static body or a rigid body or a kinematic body is in, say, the process or the physics process, we'll check for collisions. With an Area2D, it doesn't use polling as we've seen with these previous bodies. Instead it uses events or signals. And this is a design pattern called publish and subscribe. So instead of coding somewhere to say, have I got a collision, we go to this node tab and we can see here there are a number of events that the Area2D can publish. When we go to the node, we can see here that there are a number of events that are raised by the Area2D, and they belong to either other Area2D shapes entering it, which is these four, or other bodies such as the kinematic body or the static body interacting with the shape. And these signals are simply emitted by the Area2D, and it's up to other nodes to then subscribe to these events and code for them. It allows a loose coupling, so nodes that interact don't need to know about each other. So in the examples that we've discussed previously regarding the bad things that can happen by calling getParent, signals will help us to fix that problem. So in the same way that we created the collision shapes, we need to create some shapes for our Area2D. Now, and it's done exactly the same way. So what we want to do is add a collision shape, and we will add again a rectangle. So with the majority of Area2Ds that you will create, you normally have one shape which will take the outline of the node that you're creating it for. So a typical example would be a pickup where the user enters the Area2D space and they might get a pickup. Yeah, so there's no hard collision, it just raises a signal, and then in your receiving end you will handle that. So what we want to do for our Area2D is do exactly the same thing as the camera. We want a width of 512 and a height of say 2 for argument's sake, and instead of being in the same place as the room, we're going to offset it by about 16 pixels as such. Sorry, 512 should be 512 divided by 2. Okay, and the x is obviously 512 divided by 2. So as you can see, we have a Area2D, the soft collision, 16 pixels. And the reason why we pick 16 is because our sprite is 32 pixels. So when our player moves halfway off the screen, it will then trigger the event. So we will give this the name navigate up, and we can do exactly the same thing as before. Finally, we will create the right item and place it to the screen. So if we now go to room navigation, we will set the collision to be exactly the same as the room blocker, so we don't need to have any layer, and we want to look for the player bit. When we go to the nodes for the Area2D, we know that we are only looking for the player, so it is a body, and as you can see you get two methods. One is entered and one is exited. We only really need the entered event, because as soon as we hit the enter event, i.e. the player exits the screen, then we will do a page flip. There's no need to do the reverse. However, we have four shapes, so we need to know which shape of this one Area2D was entered, and in which case we can code for this method called body shape entered, which passes in a number of parameters, and one of them is the shape. Doing it this way means we don't have to have four separate Area2Ds in our node. We can just have one, but with four shapes. I don't know if there's any performance gain or loss by it, but it makes things simpler. So the way you code these events is, if you're doing it through the editor, then in this example you will double click on the body shape and it asks you which node do you want to handle this. So because we're inside the camera, effectively we can only have something from the camera downwards to handle this event. If you want to do it in code, then we can do if you want to do it from another node, then we can do it through code. But this is a simple example, so we will do it here and let the camera handle the event. The first thing we want to do is convert this local shape into a direction. So just to make sure, we'll first check that the shape is 0, 1, 2 or 3. So to convert it, we will create an array of 4 items, up, down, left and right. We will then get the direction based on the shape, 0, 1, 2 or 3. And just for some debug, we can print that out. In a full game, we might well change the code to have a room manager node, and that would be an auto load or singleton. So we would put all of these directional vectors and enums and helper functions inside of the auto load. So in our case, we'll just do it like this. So the next thing we need to do is we need to somehow tell the game that we've changed direction. And we can do that through creating our own custom signals. So if we go to the top, we can say with the keyword signal that this node can emit a signal, and we're going to call it room change. So at the bottom we can emit that signal, which is room change. So just like in the Area2D that had its own events, our game can have its own event called room change. So if we now go to our game, as you can see, we have in our game an instance of the camera, the map and the player. I'll just save this first, sorry. If we select camera, we can see here that we have the room change event. So if we double click, it gives us every node in this scene, and we want to code it against the game at the top level. And there you can see we get the method. So in other words, when our camera detects that the player has left the room, it raises a signal to say the room's changed, and we can then in our game handle that method. Now you aren't just limited to one node that can listen to an event, you can have many nodes. What we want to do is we want to manage that node, but as you can see we have no parameters, so we don't know what the room is. However, there's a handy thing in the signal system where you can pass in a variable. So we'll call it direction, and when we do our emit signal here, we can simply do, as you can see with the three dots, a parameterized query, and we will pass in change direction. So we will update this method to take in that direction that we've just created, and all we need to do is call our manage direction and pass it in. So if you recall, manage direction is the method that takes a direction and changes the game's room. So with one line of code, that is all we need. One extra thing we can do is just to make sure that change direction is valid, we can say, oops, if the change direction type is not equal to a vector2, then return. That's just in case we somehow pass the wrong data in. So let us run the code, and we will move to the left. Okay, one minor thing is I've just realized in our print statement we are outputting two entries, and I've passed in two parameters when really it should be an array. So if we run our game, we can now exit to the left. We are blocked to the right. We can let the player fall and he'll go down. We can't go back up. So what we have now is a template for a flip screen game. And all it needs now is a good idea. So if we do a really quick recap, we have our camera and we added a static body that provided a hard block to the player, and we created a single function that enabled and disabled each side of the camera. We then added an Area2D for each side of the camera, that when the player did get past the static body, it would trigger an event that would raise a signal to say the room has changed. And in our game code, we decided to handle the code at the game level and call our manage direction, which would do the page flip. Of course, in our camera there's nothing stopping us from adding multiple masks, so that, for example, we can block either through the room blocker or the room navigation enemies and other items. So that concludes the third tutorial in the flip screen. If this is all you need, then you can take the code from this and start writing your game. If you wanted a HUD on the game, in other words, this top section here, then that is what we're doing in the next and final lesson. the way we achieve this is through what's called viewports. In other words, we need to create multiple views of our game. One view would be the HUD and one view would be the tilemap. Yeah. So the reason why we need multiple viewports is currently our camera is taking up the full screen, and when we show our tilemap, it fits everything into that single viewport. So to split things up, we need to create multiple viewports. One will contain the HUD and one will contain the tilemap.